Example 5-20 says this: public opinion reported that 5% of Americans, I'm going to circle that number, that's an important one, are afraid of being alone in a house at night. If a random sample of, here's the second important piece of information, 20 Americans is selected, find these probabilities using the, it's asking us to use the binomial table. Okay. If you go to Appendix A in the back of the textbook, you will find Table B, which is the binomial table. We'll look at it in just a moment to see how it's going to help us. Okay, so what we have here is, let's look at part A. It says this: we want to know what is the probability that there are exactly 5 people in the sample who are afraid of being alone at night. Okay, so let's define a few things. We know that the value of P is equal to the probability of a success. Success in our scenario is they're afraid of being alone at night. So 5% as a decimal, 0.05. Okay. We know that N is our sample size. We know we have a sample size of 20 Americans. And we know that X equals the number of successes out of our sample that we want. In this first part, that's 5. We want to know what is the probability of exactly 5 Americans in that sample of 20 who are afraid of being alone in a house at night. Okay? Now, there's this big formula that was used earlier in this section. What it's showing us in this example is how to use a table. So let's keep these 3 numbers in mind. Okay, P is 0.05, N is 20, X is 5. Let's take a look at the binomial table. Here's what the binomial table does for us. It says, let's first take a look at our N value. N for us was 5. Okay. I'm sorry. I took a pause for a moment because I was looking at something backwards. So N for us is not 5. N for us is 20. So I'm going to keep scrolling through this until I see the section with N equals 20. Okay, it looks like we get all the way down to here. It's the 6th portion of Table B. So N equals 20. My sample size is 20. Okay. What is my X equal to? I know I want at least X equals, or not at least, I know I want 5 successes. So out of a sample size of 20, I want 5 successes. Now what's my p-value? My p-value is the probability of a single success. P for us is 0.05. So if I say N is 20, come down here, X is 5, and my probability of success is 0.05, that comes down to this value right here, 0.002. So the probability of exactly 5 is 0.002, or 0.2%. So there's less than a 1% chance that exactly 5 people in the sample will be afraid of being alone in a house at night. Good. Well, let's look at part B, because part B is a little more complex. Part B says this: there are at most 3 people in the sample who are afraid of being alone at night. There are at most 3 people in the sample who are afraid of being alone at night. Now, this actually involves multiple scenarios. At most 3, doesn't that mean either none, 1, 2, or 3? Right? Because at most 3 means 3 or less. So when we say we want to know what's the probability that X is, here's how we're going to write it, less than or equal to 3, That means at most 3, where x is either 0, 1, 2, or 3. That's less than or equal to 3. But in order to figure this out, we actually have to separate it into those 4 different pieces. What's the probability of getting nobody afraid out of our sample of 20? But then remember with or, right, we're going to use a plus the probability of getting 1, plus the probability of getting 2 people in our sample of 20 who are afraid, plus the probability of 3 people in our sample being afraid, our sample of 20 being afraid of being alone in a house at night. So we need to figure out the values of each of these. We need to figure out the probability of 0, probability of 1, probability of 2, and probability of 3. Well, let's go back to our binomial table. We're still using the section, right, where our value of n, our sample size is 20. Okay, but for us, and we're still using that the probability of success is 5%, 0.05. Right? But we want to know 3 different scenarios. What is the probability that x equals 0? In other words, there's no successes out of the 20. Look at that. That's our 0.358. 0.358. Well, what we can then do is we also want to know what's the probability that x equals 1. That 1 out of the 20. Well, that's this value here. 0.377. But we also wanted to know 2 and 3, didn't we? That's the 0.189 and 0.06. Let's transfer those over really quick. So the probability of 1 from the table, 0.377. The probability of exactly 2 out of the 20 being afraid, 0.189. And the probability of exactly 3 being afraid of the dark, when being afraid of being alone at night, is 0.06. Great, so all I have to do now is I have to add these values up. And if I do that, if I add those values up, I end up with 0.984. So 98.4%. So what does that mean? There's a 98.4% chance that if you randomly select 20 individuals, that no more than 3 of them, in other words, none of them, 1 of them, 2 of them, or 3 of them, will be afraid of being alone in their home at night.